This is the NEET 2021 question in electromagnetic induction. It says, two conducting circular loops of radii R1 and R2 are placed in the same plane with their centers coinciding, and if R1 is greater than R2. So if I have to draw the diagram, R1 is greater than R2. That means inner one is R2 and the outer one is bigger as per the problem. The outer one is R1. The mutual inductance between them will be directly proportional to. Mutual inductance comes only when a current passes through the coil. Let a current I is passing through outer coil. Let current I is passing through the outer coil. I in the outer coil. Whenever current is passing in the coil, there is a magnetic field developed around it. That's direction can be found using the right hand thumb rule that goes into the paper, right? So B due to I in the field is, we have a formula mu naught Ni by I have a formula that magnetic field at the center of a circular coil is mu naught Ni by 2R. That is mu naught, number is N is 1, current is I, by 2R means due to the outer conductor we are talking about, so that will be R1. That will be the magnetic field. Due to this magnetic field, who is there obviously developed inside due to the right hand thumb rule. If you see, if you hold your curled fingers around this circular conductor, your thumb goes inside, so the magnetic field developed is inside. That magnetic field generates a flux inside, right? So we can calculate the magnetic flux in inner circle can be found using a formula B dot A. B we already calculated, mu naught I by 2R 1. As you are calculating the flux in inner circle, area of the inner circle has to be taken, that is pi R2 square. That's the magnetic flux generated, right? But we know this magnetic flux is actually whatever the magnetic flux developed can be said as per the mutual induction law, as per law of mutual induction. The induced magnetic flux can be written like M into I, where M is called mutual inductance. So this magnetic flux can be equated with Mi. What happens then? Mu naught I by 2R1 pi R2 square equal to Mi. So this M and this I and I can be cancelled. So we can say M is proportional to, we want only the proportionality, right? R2 square by R1. That's the answer for the problem. That's how we solve that simple problem, right? Let's have a look at the other problem that was given in NEET 2020. It says a light bulb and an inductor coil. So this is the bulb, this is the coil, to an AC are connected to a AC source and a key as shown like this, AC source and key. The key is closed and after some time an iron rod is inserted between them. Now what he is saying is, within here a conducting iron rod is inserted. What happens when a conducting iron rod is inducted is, the inductance of the coil increases because it goes better through the coil, through the field, because of the iron rod. Therefore induction or the self-induction increases. As the self-induction increases, we can say the inductance of the circuit, XL, who is equal to omega L, also increases. As inductance increases, current is equal to the EMF by inductance. EMF remains constant but the denominator increases. As the denominator increases, the overall current decreases. So because of the placement of the rod, what happens is current in the circuit decreases. As the current in the circuit decreases, both are in series, the current through the bulb also decreases. That implies same current flows now. Current through bulb also decreases. As the current through the bulb decreases, it goes with less brightness, right? So what happens is that to the glow of the bulb decreases as the current is less. So the glow of the bulb decreases is the answer for the problem. That's how we have to answer that problem. Thank you for watching.